So this is the QDA1 free session taught by me. Again, my name is Aleksandra, and I'm also the tutor for the full session. But yeah, right now it's just the 2-hour free session. So thank you again for coming. Thank you so much. And if you have a question, feel free to ask in the chat or unmute yourself and just simply ask the question. I'm always open to answer anything that you may, any problem that you may have. But yeah, and when it comes to that, always feel free to ask me questions. In terms of these slides, I will send these slides to everyone through WhatsApp and then also through email, so you won't miss out on any of these. And then also there will be a feedback form after the session, which would be amazing if you could complete it, because that really lets me know what you guys like and what you guys want to see, you know, moving forwards. So those are really important things. But yeah, for today, our goals are going to be talking about the normal and standard normal distributions. So defining them, important characteristics about them, standardizing a normal distribution, so z-scores, and also moving on from there, we talk about these probabilities of standardized and normal distributions. So we're going to be using the z-table. We're going to be converting z-scores to probabilities. So we're going to be, using z-scores to find the probabilities, and then probabilities of normal distributions. So standardizing using the z-table, and then unstandardizing. So those are the main things that we're going to be talking about today. And of course, we're going to have practice questions over all of the topics covered. And if you have any questions about, like, it doesn't even have to be about today's lesson, but just about your exam, or, like, I don't know, school in general, yeah, feel free to just ask me, because yeah, I took this course last year as well. So hopefully I'm able to give you all some extra information. But yeah, that's going to be basically what we're going to be doing for today. If you are ready to start, let me know in the chat by typing yes, so then I know that we can just go ahead and jump straight into the lesson. Okay, awesome. Thank you guys. All right, so let's get started. So starting with normal distributions. So we have some basic characteristics of a normal distribution. In this case, we're assuming that the population has an infinite sample. This is when we use mu and we use sigma. And the mu represents the mean, median, and the mode. And the sigma represents standard deviation. And if you see a sigma squared, that means variance, because as we know, variance is just standard deviation squared, and standard deviation is just the square root of variance. So same, same transition. But yeah, most values on a normal distribution will adhere to the 68, 95/96%, and 99% rule, meaning that within 68% of the overall normal distribution, that means that some of those 68% of the values will fall within 1 standard deviation plus or minus from the mean. 95% will fall within 2 standard deviations plus or minus from that mean. And then 99% is for 3 standard deviations. So the way that we put this in terms of notation is in this red text that you guys can see on the bottom left corner. So we have this X with the squiggly, and then we have N, and in parentheses we have mu, and then sigma squared. And all this means is that X has a normal distribution with mu as the mean and sigma squared, or a variant, basically has this normal variance. And so an example of this, when we apply it to real numbers, is, let's say, in the case of grades. So here it's given to us X, squiggly line, mu equals 8, and variance equals 0.2 squared, or standard deviation just equals 0.2. So in this case, the way that we would actually see this on a normal distribution curve is mu, this part, this would be 8, because they gave it to us. And standard deviation is 0.2. So in this distribution, just like I wrote down here with the different calculations, in this distribution, this mean would be 8, or this mu would be 8, and then mu plus 1 standard deviation would be 8.2. and mu minus the standard deviation would be 7.8, and et cetera, et cetera. So mu plus 3 standard deviations would be 8 plus 0.6, so 8.6, and so on and so forth. So this is exactly how you would apply a normal distribution to actual values. So instead of just looking at mu and sigma all the time, it's useful to see how this would look like in a real world example. And it doesn't have to be 8, obviously. This is just in our example in the case of grades, but it could be literally any value that you're measuring. So it could be 110, it could be 200,000, it could be literally anything. So in this case, that's what the normal distribution is showing. So that's just an example. And then we need to take that normal distribution and then we're going to put it in a standard form. So instead of having all these, different values of mu, like we just saw in our grades example with, 8, 8.2, 8.6, etc., we use z-scores to make it a bit simpler. So in this case, it's a relative measure. So it's showing how many standard deviations from mu. And the way this looks like is exactly like this. So in the previous slide, we had, mu plus standard deviation, mu plus 2 standard deviations. But in this case, all you need to write is that if we have a mu at the center, as always, and then standard deviations on each side. So 1, 2, and 3, and -1, -2, -3. And this applies to any x values or any normal distribution. Any normal distribution can be standardized into a standard normal distribution where mu has a sigma of 0, because obviously at the very center you don't have a standard deviation. And then on both sides you just have 1, 2, and 3. And the way this is notated is, as you can see on the left side, we have z this time because we're working with z-scores. We have z, then this squiggly mark thing, and then we have n and 0, 1. So all this means is that mu is at the standard deviation of 0 and variance is 1, meaning that we have 1, 2, and 3 on one side and -1, -2, and -3 on the other side. So that is how we basically notate this. So standard normal distribution, z-scores. Normal distribution, x values. That's how they're different. And now we need to look at how do we actually standardize this normal distribution that we just talked about into the one with z-scores like you see here. So in order to turn x into z, we have this formula. And this formula is also in your formula sheet. It will always stay there. Don't worry, you don't have to memorize it. But this is what z would equal. So you take the x value that you're given minus mu divided by the standard deviation. And the squiggly mark in the n01, that's just continuing on this assumption that mu is at standard deviation of 0 and then the variance is 1. So that's the way we change the x into a z-score. And if we wanted to go backwards, if we were given a z-score and we wanted to change it back into an x value, then we would just use this exact formula. X equals mu plus the z-score times the standard deviation. And we're going to see some examples with both of these. So don't worry just yet about applying them. So this is basically the standardized normal distribution. And now, like I just said, let's look at an example. So we had our grades example that I used in some of the previous slides, which is where we were given mu of 8.0 and a variance of 0.2 squared, which means a standard deviation of 0.2. So again, I just put the important formulas that you'll need for these examples up here. So you have z equals x minus mu over sigma, and also x equals mu plus z times sigma. So we're starting out with this graph on the right. This is a normal distribution curve. This is a normal distribution where 8, like we are given in our example, is the mu, so it's at the very center, and the standard deviation is 0.2, meaning that we have 8.2, 8.4, 8.6 on one side, and basically the opposite on the other side. So this is our normal distribution curve. And now we should standardize it. So in this case, we want to change this 8 into a 0, because remember, the mu is always at the standard deviation of 0. So we turn this 8 into a 0, this 8.2 into a 1, 8.4 into a 2, etc., etc. So this is exactly how standardization works. We move from these top values in the original normal distribution, and then we standardize them in terms of standard deviations. And those are the new x values at the bottom. So they mean basically the exact same thing, except one is standardized and the top one is not. And so now that we have these two basically next to each other, let's look at an example. So in this case, find the z-score of x equals 7.8. So this basically means how many standard deviations is 7.8 above or below this mean that we were given. And in this case, we know it's going to be below because our mu is 8.0. So in this case, let's now just apply the correct formula, and then we can easily find out what this is. So find the z-score of x equals 7.8. So we use the left formula, so the z equals formula. We were given 7.8, so that's our x. And then we minus mu, which was 8.0, which they gave us. And then, and then we take all of that and divide it by the standard deviation, which is 0.2, which is another thing that they gave us. So from there, all we do is now we have 7.8 minus 8.0 is negative 0.2. Divide that by 0.2, and we get a z-score equal to negative 1. So that's exactly how you would solve this type of problem. And if you want a visual of how that actually looks like when we translate it, we started out with this 7.8. And when we standardized it, it became a negative 1. So as you can see, 7.8 lies one standard deviation below the mean, which is exactly what this standardized normal distribution is showing us. It's showing us negative 1, meaning that this x value lies negative 1 standard deviations away from the mean. So this is exactly how they translate to each other. Any questions so far before you guys do a practice question on your own? All right, no questions so far. So now let's have you guys do a practice problem on your own. Oh, let me remove some of my annotations. But yeah, this time I want you guys to try to find the z-score when x equals 7.66. So same process as before. Message me privately in the chat your answer or just write it down. And in a few minutes, we will go over this one as well. All right, I'm gonna go ahead and work through this one. If you're still working, you can just work with me and then I will let you guys know the right answer. So this time you try find the z-score when x equals 7.66. So just like how we did in the previous example, we have z equals, and then in this case we have 7.66 as our x value. Then we subtract it from the mean, which is 8.0. And we divide it by 0.2, which is our standard deviation. And you should have gotten z equals negative 1.7, which is exactly what most of you guys got that messaged me, which is awesome. So z equals negative 1.7. And again, how this would translate into visually. So we have x equals 7.66. So probably somewhere over here. And when we standardize it, it becomes negative 1.7, which is exactly what we see here. Basically, you just standardize it and it goes from being 7.66 to negative 1.7, which means that this x value of 7.66 lies 1.7 standard deviations below the mean, or below 8 in this example. So that's exactly how we would do a standardization problem. And last practice question that I want you guys to do is doing the opposite. So try to find x given a z-score. So you need to use this second formula that's up on this slide. And again, let me know what your answer is, and then we will go through it together and then move on. All right, I'm going to go ahead and go through this one as well because it's pretty straightforward. So in this case, we have an x value, we have a z-score, and we are trying to find the x. So in this case, we use the second formula. So try to find x given z equals 2.1. So all we need to do is just plug in the relevant value. So our mu is 8.0. Our z given to us in this example is 2.1. And we multiply that by the standard deviation of 0.2. So if you plugged it in correctly, then you would get that x equals 8.42. So in this case, we have basically unstandardized it from a z-score. So whenever we draw this one out visually, I'm going to use a different color. So in this case, we were given z equals 2.1, which is probably somewhere over here on this purple line that I just drew. And whenever we unstandardize it, we get around 8.42, which is exactly what it has right here. So in this case, the grade that is associated with 2.1 standard deviations above the mean is 8.42. So 8.42 lies 2.1 standard deviations above the mean. So that's exactly how we would apply these standardization and unstandardization examples. So really great job, guys. This is really good and really important for you to be comfortable with. Just plugging in these correct values. Once you're comfortable with this, then that's totally fine. So now that we're comfortable with standardization and normal versus standard normal distributions, we're going to move on to probabilities. So in this case, we're only right now going to be working with standard normal distribution. So we're only going to be talking about z-scores and the z-table. So we're going to be talking about what these probabilities mean, do some examples using the z-table, and more practice questions. So that's what we're going to be doing in the next part of this lesson. So in this case, let's start out with just probabilities of these standard normal distributions. So these probabilities can be between 0 and 1. We obviously can't have a negative probability, and there can't be a 120% chance of something happening, only 0 to 1. And there's no negatives, like I just said. So these probabilities are represented in the z-table. And these are cumulative probabilities. So this is based on the cumulative distribution function, or CDF. And this basically shows the standard normal distribution in terms of cumulative probabilities. And how that looks like is just like this. So on the x-axis, we have standard deviations, so from -4 to 4. And then on the y-axis, we have probability density. So all this is showing is just another form of how a standard normal distribution looks like. So in this case, the entire area underneath this entire curve is equal to a probability of 1. So if you added together all of these areas separately together, you would get a probability of 1. So in this sense, it's a cumulative probability, because let's say the probability that a z-score is, I don't know, less than 0, that's the entire area to the left of 0. So in this case, all the probabilities, same on the z-table, are cumulative. So they're talking about the left area of a z-score. And you guys can see this on your formula sheet, actually, like on your formula sheet that shows the z-table. It shows a picture of a standard normal distribution curve, and it has the area to the left shaded, because that is always the case. If we have a z-score and we look in the z-table for that probability is showing us the left area of that z-score. So that's an important thing to remember whenever we're talking about probabilities with z-scores. And from this, now we can basically take a look at how a standard normal distribution would look like with probabilities. So in this example, we have the probability that z is less than 1.0. So what is the probability that there's a z-score less than 1? So that means that how would this look visually? And then also we use the z-table to find this area. So probability that z is less than 1.0 looks like this whenever we take it in terms of a standard normal distribution. So we have 1, a z-score of 1, and all of the areas shaded to the left and underneath the curve of the standard normal distribution is the probability. So this entire gray area represents the probability that this z-score is less than 1. And this is really similar to how it's shown in your z-table formula sheet. So you won't forget that the areas in the z-table are always talking about the areas to the left of a z-score. So in this case, now let's take a look at this z-table. So how do we use the z-table, and how do we read it? So going back to this example, the probability that z is less than 1. So again, we have the curve drawn right here with the area shaded in. I always recommend that you guys draw the curve and shade in the area that is relevant because visually I think it's really helpful. And so whenever we're using the z-table, we start with the rows and then we go to the column, because with the row labels, so these ones, the ones I'm talking about, these are the ones that are talking about the first and the 10th place of numbers. So this is talking about the 1 and the 0 of this example. So we always start with the rows because those are talking about the first and 10th place. And then we move on to the columns, which is talking about the hundredths place. So 0.06, 0.07. In this case, our hundredths place is 0 again, because we're looking just for 1.00. So in this case, we have this probability that we're trying to find. When we look in the z-table, like I said, we start with the rows. So in this case, we have our row, so 1.0, because our z-score starts with 1.0. And then we move on to the columns, which is 0.00, because that's exactly what our z-score says. So in this case, we see where they intersect, and that probability that z is less than 1.00 is 0.8413. So this is 0.8413. That's exactly how you would write the answer. So you just say this equals 0.8, wow, oh my God, 413. There we go. So that's exactly how you would write it in a problem. And all this probability is representing is saying that basically the probability that you'll have a z-score less than 1 is 0.8413 or 84.13%. So that's exactly how this problem is shown. So is this clear to you guys? Let me know in the chat. Type yes in the chat if this is clear for you guys. All right, awesome. Yeah, it's really important to know how to read the z-table. So the more you practice with it and the more comfortable you are with it, it's going to be really, really helpful for you. How do you get the z-table? So on your formula sheet, so you have a formula sheet with like the actual formula, so like z equals blah, 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 like the formula for standard deviation. And then there's another formula sheet that has the z-table and also the t-table, which I believe you guys will be using this week. And those both will be given to you on the exam, and also you can find them on Canvas, I believe, like underneath the, I don't know, course information page. There will be like the formula table for like actual formulas, and then the page for z-tables and t-tables. So you don't need to memorize. So yeah, you don't need to memorize the entire z-table, but you should remember obviously how to use a z-table. But yeah, like you should be comfortable with using a z-table, but you don't need to memorize every single probability in the z-table. Yeah, that would be really mean. Yeah, so don't worry about that. You will be given the z-table, the t-table, and the formulas on the exam. So don't worry about that. All right, so now that we've looked at how to use the z-table, so now let's look at some different scenarios. So our z-score that's going to be given to us may not always be such a nice number as 1. And also the inequality may not always be less than. So it may not always agree with the areas that are given to us on the z-table. So in this case, our previous example on the previous slide was what was the probability that z was less than 1? And in this case, we're trying to find the probability that z is greater than 1. So in this case, I have the standard normal distribution here so that we can draw it out, because I always recommend that you draw out the probability that you're trying to find. So in this case, how do we find the probability that z is greater than 1? So we have our z-score of +1, and it's asking for the probability greater, which means the entire area greater than 1 is the probability that we're trying to find. So this whole area is what we're trying to find. Right here, this red one. So first, you shade in the relevant area that you're trying to find. Always super important. Then, since the entire area underneath the curve is equal to 1, we can say that this probability, or this red area, the probability that z is greater than 1, is the same thing as saying 1 minus the probability that z is less than 1. So remember, in the z-table, they will never give us probabilities on the left side of the z-score. So this does not show up. This does not show up in the z-table. The z-table will show us this area, which I'm going to color in purple, this entire area. So the z-table will only always give us the probabilities to the left of a z-score, which means that in this case, whenever we're trying to find the probability that z is greater than something, or this red area, we can take this whole area, this entire area of this entire curve, which is equal to 1, and we can subtract the purple area in order to get the red area. So this probability that z is greater than 1 is just like saying 1 minus the probability that z is less than 1, or this purple area. So in this case, we need to write it like this in order to be able to use the z-table. So now that we've rewritten it as 1 minus the probability that z is less than 1, this probability that z is less than 1, this one, does show up in the z-table. We just did it in the previous slide. So in this case, now that we've put it in terms that we can actually find in the z-table, all we need to do is go look in the z-table. So this probability in the z-table, the probability that z was less than 1, was equal to 0.8413. So now that we've looked in the z-table and found this, now all we need to do is just say that the probability that z is greater than 1, which is what we were given in the first place, is the same thing as 1 minus 0.8413, which means that the probability that z is greater than 1 is equal to 0.1587. So that's exactly how we would solve a problem where the inequality sign is showing greater than rather than less than. So this is with a positive number and a greater than inequality sign. However, as always, there's a lot of different scenarios in terms of z-scores and their probabilities. So now we're going to look at some negative z-scores, because we're not always going to work with positive ones, or they're not going to always ask you about positive ones. So in this case, how do we find the probability that z is less than -1? So as always, we should shade in the relevant area that we're trying to find. So let's get rid of all of these. And now we're asking about the probability that z is less than -1. So in this case, we have -1 this time that we want to find, and the probability that z is less than -1. Like this. However, now the issue is that there are no negative z-scores in the z-table. So we can't use the z-table with a negative value. In this case, we need to change this to be from a -1 to a +1. But whenever we do so, we need to flip the sign as well. Because when we say the probability that z is less than -1, it's this green area. That's just like saying the probability that z is greater than 1, greater than +1. The areas are the exact same because this standard normal distribution is perfectly symmetrical. -1 is on one side, 1 is on the other side, perfectly symmetrical. So just like z, the probability that z is less than -1, that shaded area is the exact same thing as saying the probability that z is greater than 1. And remember, whenever we need to get rid of a negative, we always need to change the inequality sign. So as you can see here, the inequality sign went from a less than to a greater than sign whenever we multiply this -1 by -1 to make it positive. So in this case, now that we've changed the z-score into a positive number, we can now move forward and see how we can use this in terms of the z-table. And in this case, we've just changed this original probability that we were given into one that we used and we found out in this first example. As you can see, probability that z is greater than 1, probability that z is greater than 1 up here, sorry. So in this case, now we just do the exact same steps that we did for this first example, and then we just solve it the exact same way. So in this case, we were at first given, the probability that z is less than -1. We changed that so that the -1 would be positive. We flip the sign. So remember that the probability that z is greater than 1 is just like saying 1 minus the probability that z is less than 1. So in this case, we just solve it the exact same way that we did it in question 1. So 1 minus 0.8413. So therefore, we can say that the probability that z is less than -1, like we were originally asked, is equal to 0.1587. So it's the exact same way that we did it in example 1, except in this time, the first thing that we were given was a negative number, which we then had to translate into a positive number and then solve for the probability. And so now we have this example, and the last way that we can be given basically a probability of a z-score in terms of negative numbers, inequality signs, is this way. So how do we find the probability that z is greater than -1? So as always, let's draw it out. So we have the probability that z is greater than -1. So we're going to start with this -1 z-score again, right here. And now we're looking for the probability that z is greater than -1. So this whole area over here, this whole purple area to the right of z equals -1. So this is the whole probability that we're looking for. And so now that we've shaded in the relevant area, remember that we need to change this -1 into a +1, because as always, we don't have negative values, negative z-scores in the z-table. So we can't use the z-table until we've changed that -1 into a +1. And when we do so, remember, as always, we need to change the sign as well. So this was a greater than sign before, and now that we've changed the sign from a -1 to a +1, we also need to change the sign from greater than to less than. And now that we have this probability that z is less than 1, we can look directly in the z-table for this probability, because as always, the z-table is going to show us the area to the left of a z-score. And since this is asking us for the area to the left of 1, we can now just look simply in the z-table and get the right answer. It's the exact same way that we solved the very first example that we did on the previous slide. So probability that z is less than 1 is in the z-table. So all we need to do is just look in the z-table and find that the probability that z is less than 1 is 0.8413. And then from there, we just need to rewrite this as the probability that z is greater than -1 equals 0.8413. And that's exactly how you would write the answer to this question. So I know there was a lot of different scenarios, a lot of different examples, but are there any questions about how to approach these types of probabilities? All right, so I'm not getting any questions, so I'm hoping that this makes sense. And don't worry, we're going to keep doing some more examples with this, just so you guys get really comfortable. So now I'm going to just go ahead and clear everything, and then let's move on to the next part. So one thing I want to note is working backwards. So what if the probability was given but not the z-score? And so back to our z-table, let's look at an example. So what is the probability given 0.9, but what is the z-score associated with that probability? So what is the probability that z is less than something equals 0.9? So this time we have to start by looking within the table. So we don't look at the outside because those are talking about z-scores and we don't know the z-score yet. And the inside is all about probabilities. So that's where we're going to look first. So we look within the table and we find the value closest to the probability that we're trying to find. In this case, it's 0.90000 in this case, because all of these probabilities are 4 decimal places. So we're trying to find the probability closest to 0.90 onwards. So once we find that number, then we find the row and column that matches that value. So in this case, we're trying to find this 0.9000. And so we're looking, and the closest two values that are to 0.900 are these two right here, 0.8997 and 0.9015. And in this case, the correct or the closest value to 0.9000 is going to be 0.8997, because that's only 0.0003 away from being 0.9, while the other one is a little bit farther, at a little bit too much, versus the 0.8997. So in this case, this is our closest value, or this is our closest probability to the one that we're trying to find. And so now that we've found this probability, we need to match up and find the row and the column that it belongs to. So in this case, we find that 1.2 and then 0.08 are the correct rows and columns that match up with this 0.8997. So therefore, we can say that the probability that z is less than 1.28 is equal to 0.9000. So this is the closest probability in the z-table, and this is the closest z-score that is going to get us the probability that we want. So this is how you would approach a question like this, where you're given the probability but don't know the z-score. It's the exact same process, just inside out versus outside in. So that's an example with working backwards. Any questions about this? All right, I'm not getting any questions, which I hope is okay. Please tell me if there's something that is confusing you. I just want to make sure that it's super clear to you guys and you guys are really comfortable with this. So as always, don't be afraid to ask me a question. So now that we've done a little bit of this working backwards, let's take a quick break. And then when we come back, we're going to practice some intervals with probabilities and then put it all together with normal distributions. But I will put the time in the chat when we should all come back to the class and then move on. So right now it is 12:45. So let's say at 12:55. So in 10 minutes, let's all come back and then we will continue on with the lesson. So I will see you guys then. All right, everyone, let's get settled in again. And then let's finish up the last little bit of this lesson. We're going to be talking about intervals with probabilities and the z-scores, and then doing some more examples, and then just applying everything together, starting from x values into z-scores, and then finding the probability and then changing it back to an x value. So that's what we're going to be doing for the rest of today's lesson. And yeah, if you guys have any questions about anything regarding your exam or anything, then we can also talk about that a little bit at the end of the lesson. But for now, let me know in the chat, type yes, if you're ready to move on to the next part of this lesson. All right, thank you, Martin. Thank you, Eva. Thank you, Sylvie, Mateo, Yana, Christian, Lily. Thank you so much. All right, awesome. So now let's move on to intervals, like I just said. So very, very similar to one-sided probabilities in the way that we're going to solve these intervals. And these intervals can be the space inside or outside two z-scores. So you can have something like find the probability that z is in between -1.3 and 1.6, or you could have something where they're asking you find the probability that z is less than -1.3 or z is greater than 1.6. So it all depends on, what they're asking you, and then that obviously influences what you're going to be doing with that problem. So how do you find the probabilities of these intervals? So it's really actually similar to one-sided or just one z-score, but you just need to account for these two z-scores together. So in this case, again, I always recommend that you draw the distribution curve to help you identify what area you're trying to find. So in this case, now let's do an example. So we have the probability, or we're trying to find the probability that z is in between -0.46 and 1.8. So let me draw the area as always, like I recommend. So we have -0.46, which is probably somewhere right here, and 1.8, which is probably somewhere right here. So we're trying to find this blue area. So this entire area in between these two z-scores right here. So this is the area that we're trying to find. And so in this case, we are trying to find this area, and there's a few steps that we should take to find this. So we should we should basically draw the curve first, like I just did, and shade in the area that we're trying to find. And then we need to split up the interval into two separate parts. And the reason why I drew I wrote this interval slightly differently than what it says here in the problem is because the way we're going to solve for this interval is by subtracting the larger or the rightmost number from the leftmost. So what I mean by that is here I've written probability that z is less than 1.8, which is exactly the same as what I wrote or what is in the interval question. So the probability that z is less than 1.8 is this entire red area. So basically anything from z, anything underneath the curve from this 1.8 onwards, like all of this entire area, that is the probability that z is less than 1.8. And then if we have the probability that z is less than 1.4, I'm sorry, z is less than -0.46, we're talking about this area, this green one right here. So this is the probability that z is less than -0.46. And we're trying to find this blue area. However, the way we're going to find this blue area is we're going to take this entire red area, which was the probability that z is less than 1.8, and then subtract the green area from the red area in order to be left over, to have the blue area left over. So again, I'll draw it again for you guys right here. So we have the standard normal distribution curve, and then we have the probability that z is less than 1.8. So let's pretend that here is our mean. Yeah, don't worry, I will repeat the last part. So we have basically the probability that z is less than 1.8. So that is this whole red area right here. So the probability that z is less than 1.8 is this whole red area. And the interval that we're trying to find is between -0.46, which let's just say is right here, and +1.8. So we're trying to find this blue area. And then if we have the probability that z is less than -0.46, so let's say again 0.46 is right here where this purple is, and anything below -1.46 is this purple area. So the way we solve this type of problem is we say the probability that z is less than 1.8 minus the probability that z is less than negative 0.46. And if we take this red minus this purple, we're left over with the blue part that is our interval. That equals the probability of just our interval. So we take the rightmost area, or the rightmost part, so this z less than 1.8, we subtract it from the left side, so z is less than negative 0.46, and we're left over with the area that we need. So that's exactly why I wrote it like this, that probability of z is less than 1.8 minus probability that z is less than negative 0.46 is basically equal to our interval. So then we basically just solve for both parts separately and we subtract to get the middle area. So that's exactly how we are going to basically approach this exact problem. So now that we know exactly what we're going to be subtracting, I'm going to go ahead and type out like the steps. So we're going to start out with the probability that z is less than 1.8 minus the probability that z is less than negative 0.46. So then the next thing we need to do is just basically solve for these z scores individually. So I'm going to go ahead and tell you guys what the z table would say. We're going to do another example where the z table is next to us, but for this one, I didn't have enough room on the slide. So in this case, the probability that z is less than 1.8, we can easily find that in the z table, and that probability is 0.9641. And then we subtract that from the probability that z is less than negative 0.46. But remember, we cannot find a negative z score in the z table. So in this case, this probability that z is less than negative 0.46 is just like saying the probability that z is greater than positive 0.46. And then since we have a greater than sign, we can't find the right area in a z table. So all we do now is just take this 0.9641 and we subtract it 1 minus, and then the probability that z is less than 0.46. So now that we've done that step, we can finally do 0.9641. And I'm just going to go ahead and tell you what this right here equals. So it's 1 minus 0.6772. And that whole thing is equal to 0.6413. And I'm actually going to change the color of this because it's a bit hard to see. So yeah, here we go. So we started out with this original interval, then we split up the interval into two separate parts. So we have the bigger section minus basically the smaller section. So this blue area minus this red area minus the purple area. And then we basically just look in the z table for those individual z scores, and then we solve. So we ended up with 0.6413. And so the final answer is the probability that z is in between negative 0.46 and positive 1.8 is equal to 0.6413. So that's exactly what our blue area equals. So this blue area that I shaded in on both standard normal distribution curves that I drew, that blue area is equal to 0.6413. So I know it's a little weird to like switch the one part of the interval, but that's going to be the easiest way for us to actually find the interval area. So we subtract the overall big area minus the smaller area that we don't want, and then what's left over is the interval that we need. So that's exactly how we would solve this type of problem. And don't worry, we're going to do an example together on the next slide that is going to have also the z table, so we can do all of the steps. Does this apply? Only apply to normal distribution. So this this probability will apply to basically any distribution. It just depends on what formulas you use. or what table you use, because if we're talking about like hypothesis testing, you're going to use the t-table and a different formula, so not necessarily z. But in this case, whenever we're talking about using the z-table, this is applying to normal distributions. So yeah, this will apply to normal distributions and standard normal distributions like we're seeing here. But for like some of the other types of tests that you guys will learn about this week, you're going to use a different table. So in this case, if you see capital Z's and probabilities that, you know, capital Z's are this, you can pretty much use the Z table and it'll be fine. Okay, so let's do another example on the next page, just so you guys get a little bit more comfortable with this, and then you'll do one on your own as well. So let's practice. Now we're going to try to find the probability that Z is in between 0 and 1.48. So again, as always, I have the standard normal distribution curve up here. And then we're going to shade it in and then do all of the necessary steps and then find basically the area. So in this case, we have 0 as our left value or left z-score, and then 1.48 as our right one. So this is basically the area that we're trying to find, this blue area right here. So now that we've drawn the area that we're trying to find, we need to split up this interval into 2 different parts. So again, we take the rightmost, or the 1.48, and we say the probability that Z is less than that 1.48 minus the probability that Z is less than 0. So I know it says in the interval Z is greater than 0, but the way we're going to find that interval is we're taking basically, again, let me draw it out. So let's say this whole area, probability that Z is less than 1.48 is from the 1.48 all the way until basically the end of the curve. So this entire area underneath this entire curve from below this 1.48 is this part. And again, the interval that we want, or this area that we want, is the dark blue area. And the way we're going to get there is we're going to take this Z is less than 1.48 and subtract it by the probability that Z is less than 0. And that's going to be this entire green area. So we take this light blue minus the light green from it, and we're left over with the dark blue area. So that's why, again, we have to split up this interval into these 2 parts and then subtract the rightmost z-score from the leftmost z-score probability to get the leftover interval value. So again, that's the easiest way to find the probability for an interval. So now that we've basically established that, we can now try to find these individual probabilities. So actually, I'm going to first look in the z-table for these. So probability that Z is less than 1.48. We can easily find that in the z-table just because this is a less than sign and it's already a positive number. So we don't need to really do anything else with this. So now that we have the probability that Z is less than 1.48, now let's find that. So we have 1.4, and then we have to go all the way down until 0.08. So in this case, we have 0.9306. So this probability is equal to 0.9306 minus something. And we don't know what that minus is yet, because now we need to find the probability that Z is less than 0. And this one's pretty easy to find because it's the very, very top left corner value, 0.000. So 0.5. And so now that we know both probabilities, we have 0.9306, we minus 0.5000 from that, and that gets us an answer of 0.4306. So now that we've known that, we can rewrite this as saying the probability that Z is in between 0 and 1.48 is equal to 0.4306. And that's exactly how you would solve this type of problem. So we are having an interval, then you basically shade an area, split them apart, starting from the rightmost side, minusing it from the left, and then looking in the z-table for those probabilities, subtracting them from each other, and then that leftover probability is your interval area. Any questions about this? All right, so now I'm going to give you guys a problem to try out on your own. I'm going to leave the z-table and everything up here because you will need it. And then I will give you guys a few minutes to do this next problem on your own. And then I will go through it together with you guys as well. So now that we've done one interval on our own, let's try this one. So I'm also going to erase my... All right, I'm going to go ahead and work through this one. If you're still working, then don't worry, I won't say the answer until the very end, so you can keep working. But yeah, for this one, find the probability that z is in between negative 1.4 and negative 0.66. So now let's first, as always, just draw it out and see what this looks like. So we have negative 1.4, which is probably somewhere over here, and negative 0.66, which is probably somewhere right there. So we're trying to find this purple area right here, this interval. So now that we've identified what interval we're trying to find, we also need to write it out. So now we have basically the probability, and remember we always take the right part of the interval, so probability that z is less than negative 0.66 minus, and then we take the left part of the interval, then we take minus the probability that z is less than negative 1.4. So as always, we always first write our interval just like this. And so now we need to find this interval using the z-table. However, as you can see for both of these values, they are negative values. So we need to change these into positive values before we can think about using the z-table. So we need to change both of these values. So this probability that z is less than negative 0.66 now becomes the probability that z is greater than positive 0.66. Because remember, whenever we change negative values, we need to also flip the sign. So now that we have probability that z is greater than 0.66, then we also have to do the same thing for this probability. So the probability that z is greater than 1.4. So now that we've changed it into positive numbers, that's a great first step. And now what we need to do is fix the inequality sign, because as we know, the z-table is only going to give us the areas to the left of a z-score. And these right here are asking us for the area to the right of a z-score. So before we can fully move on and actually find the probabilities of these z-scores individually, we need to take 1 minus both of them. So 1 minus the probability that z is greater than 0.66, and then we take that whole thing, put it in brackets actually, we're going to take that whole thing and subtract it from 1 minus the probability that z is greater than 1.4. So remember, for both of these, since they both say greater than, we need to take 1 minus that value, because as always, we're looking for the value to the left of a z-score. So now that we have this written out, we can actually look in the z-table and find what these probabilities are. So for the first one, 1 minus the probability, and this should be less than, and I'm sorry, this should also be less than, my mistake. So now that we have this 1 minus, let's now look in the z table for these values. So the first one that we're looking for is 0.66. So let's look for that in the z table. And as you can see, 0.66, so we have 0.6, and we just need to move all the way down here to get 0.66. So that gets us 0.7454 for the first probability, 0.7454. So 1 minus 0.7454 is the first one that we need to have. And then we have to do minus, and then we have 1 minus. Now we need to find the probability of 1.4. So now let's do that one with the z table. So let's find 1.4, which is right here. Here's 1.4, and we're looking for 1.40. So this one right here, 0.9192, is our probability that z is less than 1.4. So let's also add that, type that one in here. So probability that z is less than 1.4 is 0.9192. So now that we have everything written out together, let's solve. So we have, let me just move it up here so you guys don't get confused. So we have 1 minus 0.7454, and then you take that whole thing because that represents the probability that z is less than negative 0.66, and then we subtract that from 1 minus 0.9192 because that represents the probability that z is less than negative 1.4, like we had originally written. So now once we do all of that math, we get the probability that z is in between negative 1.4 and between negative 0.66. We get the answer equal to 0.1738. So that is the basically area, that purple area that we drew in, that is the probability that z is in between negative 1.4 and negative 0.66. So that was, I mean, I know it's a lot of extra steps because, you know, first it's negative, and you have to change to positive, and then you have to account for the signs. But this is exactly how they would probably, like, this is kind of like the level that they would ask you if you had to find some sort of interval like this by hand. So it's really good to get in this type of practice and be really comfortable with doing these types of intervals. So I hope this makes sense as well, these types of interval practices. And yeah, it's just about being comfortable with it. There's nothing to, you know, like super complex. It's just about getting in the practice and being confident in your answer. So I think that's the main thing I would recommend for you guys. So now that we worked with intervals, whenever we know the z-score, we also need to think about what if the probability is given and not the interval, because this will happen sometimes. A lot of times this happens whenever they give you, you know, like a, when they're asking for maybe like the shortest possible interval or, you know, something like that, they don't tell you the z-scores, but they tell you the probability. So let's say in this example, we see that the probability that z is in between two values is 0.95. So in this case, and in all cases actually, we assume that A and B are symmetrical. So they're the same exact value, except one is negative and one is positive. For example, if let's say the probability that, I don't know, it was like 0.9 or something, and we found that the z-score on one side was equal to 2, that means that the other side would just be negative 2, because we always assume that A and B are symmetrical to each other, except A would be negative and B would be positive of that number. So in this example, the probability that we're given is 0.95. So in this case, we, as always, assume symmetricity, and then we draw it out as always. So in this case, I'm gonna go ahead and draw it. So we have A and B. So on one side we have A, and on the other side we have B. They're perfectly symmetrical. So the value of B is just the negative number. That negative number equals A. So this entire shaded area in between A and B, in between this entire interval, is equal to 0.95, which is given to us. So this whole interval in between A and B is equal to 0.95. And then what is left over of that 0.95? So what is not accounted for in the interval? And so what is not accounted for is written right here, 1 minus 0.95, because remember, the total probability underneath, or the total area underneath the curve, is equal to 1. And the area that we've accounted for with this probability is 0.95. This means that we have 0.05 left over in total that this interval doesn't account for. And so this 0.05, since we're assuming that this amount or these intervals are symmetrical with each other, we assume that half of this 0.5, which I'm drawing in blue on the distribution curve, half of that 0.5 is going to be on the B side, and half of the 0.5 is going to be on the A side. So half of this 0.5 is going to be over on this side, and then half is going to be on the other side. So if we divide 0.05 by 2, we get 0.025 on both sides, which makes sense. If we added together 0.025 plus 0.025 plus 0.95, which is the interval probability, we would get 1, which is exactly what we should get. So this is the amount of probability on each side that is not included in the interval. And it's important to note that as well. So now that we've basically drawn out where the interval is and then the areas on both sides that are not included in the interval, it's going to make it a lot easier for us to find the A and B values. So we already did the first step, which is draw and find an unincluded area. So the unincluded area is 0.05 total, so 0.025 on each side, like I just drew here in the pink and the blue. And then, as always, we separate the interval, which is exactly what we did in our previous interval examples. We know that the probability that Z is less than B, or the rightmost Z-score, minus the probability that Z is less than A, which is the leftmost Z-score, we know that that is going to be equal to 0.95, which is exactly what we were doing in the previous examples as well. We took the rightmost one, subtracted it from Z is less than the leftmost Z-score, and that got us our interval value. So the same exact thing applies here, where we have this exact equation that I just showed you guys. So Z less than B minus the probability that Z is less than A, and that equals 0.95. So now starting from here, we always start with the right tail, or B in this case. So the rightmost Z-score, and then we use the Z table. So now we start with the probability that Z is less than B. And when we try to find the probability that Z is less than B, we know it's equal to 0.975. And the reason why we know that is because, I'm going to draw it in green. So we have, actually, no, I'm going to draw another curve right here. So as always, we have the mean, and then we have A is over here and B is over here. So A and B. And remember that the probability on the inside is this pink area. So anything underneath the curve between A and B, that is equal to 0.95. And on both sides, like I had drawn in light blue, these two, one is equal to 0.025, and so is the other one, 0.025 and 0.025. So we know that. And so now we're trying to find the probability that Z is less than B. And what does that probability equal? So if we have the probability that Z is less than B, we're talking about anything to the left of B. And that includes both this 0.95 and this 0.025 that was technically not included in the interval. But since we're trying to find just the probability that Z is less than B, we take into account both of these areas. So that's how we know that the probability that Z is less than B is equal to 0.975. This 0.95 from the interval plus this 0.025 that's technically not in the interval, but it does count whenever we're just talking about Z is less than B. So now that we know this probability is equal to 0.975, all we need to do is just look in the z-table and find the z-score that matches with that probability. So we have 0.975, and I'm just going to go ahead, and in the z-table, we actually have 0.9750 perfectly written, as you can see right here. Actually, I'm going to change the color because it's a little bit hard to see. So in red, as you can see right here, 0.9750 is perfectly in the z-table as a probability. And if we line that up with the rows in the column, so 1.9 and then 0.06, we see that the probability that z is less than 1.96 is equal to 0.975. So that's why we start with one side. So if we know the probability that z is less than 1.96 is equal to 0.975, we always assume symmetricity. So if we just found out that the probability that B's z-score is equal to 0.196, like I'm drawing up here, we assume symmetricity. And this means that if the probability that z is less than 1.96 is equal to 0.975, we assume that A is equal also to 1.96 except negative, because we're assuming that the length is symmetrical with the mean value. So all we have to write here is that the probability that negative 1.96, z is in between negative 1.96 and 1.96, that probability is equal to 0.95. And the way we can double check this is by solving. So let's say that we wanted to actually solve this problem and say, okay, well, let's pretend we don't know the probability, but we know these two z-scores, and they are our interval. So in this case, as always, we take the probability that z is less than 1.96 minus the probability that z is less than negative 1.96, as we always do. Then from there, probability that z is less than 1.96 is 0.975, like we just found, minus, and remember this is a negative value, so this becomes z is greater than 1.96, so we have to take 1 minus the probability that z is less than 1.96, and then that equals 0.975, and 1 minus 0.975. And so as you can see, 0.975 minus 0.025 is equal to 0.95, which is exactly the interval that, which is exactly the probability that we found whenever we were trying to find the z-scores. So 0.95, they should equal the exact same thing. So if you worked through this problem the way you normally would if you were given the z-scores and not the probability, you would get the exact same answer as if you were trying to find the z-scores while given the probability. So we were given the 0.95 but not the z-scores, and then we found the z-scores, negative 1.96 and positive 1.96. And then if we tried to solve for the probability, given those two values, we would have gotten 0.95 as well. So in the end, you can always actually double check your work by doing the opposite. So if we were trying to find the z-scores, let's check our work by trying to find the probability. And that's exactly what we did in this problem. So are there any questions about this? All right, I'm not getting any questions. Can you explain step 3 one more time? Yeah, for sure. So I'm starting with the right tail and then using the z-table. So actually, oh my gosh, I drew a lot. So I'm gonna actually, let's see, I'm gonna erase this part. So so we started with the right tail, and what I mean by the right tail is B. So we have A on one side of the interval and B on the other side of the interval. So we start with B because it's much easier in the z-table to find the probability that something is less than the rightmost side. And whenever we're trying to solve for an interval and we're given the z-scores, we always start with the rightmost side, just like how we did in step 2 when we separated the interval. So if we're trying to find the probability that z is less than b, we need to find out what that probability equals so we can find b. So in this case, we know that the probability that z is less than b is equal to 0.975. And the reason why we know that is because the probability that z is less than b is just like saying the probability that basically it's combining the interval probability with the leftover probability on the leftmost side. So I'm going to try to find a place where I can draw this actually. So I'm going to draw in dark blue on the normal distribution curve in the bottom left. So right here, this is where I am. So we're trying to find the probability that z is less than b. And the way we're going to do that is the probability that z is less than b is anything from this value of b that we don't know yet, anything to the left of that b value underneath the curve. And that includes both the interval area of 0.95 and the area of 0.025. Because remember, in the very beginning, we said that there was 0.025 on both the left and right sides of this interval that were not accounted for. And in this case, whenever we're just trying to find the probability that z is less than b, we're talking about the area underneath the curve to the left of b, and that includes both the 0.025 and the interval area of 0.95. So if we add those two together, we get 0.975. So that means that this whole area to the left of b, this whole dark blue area, all of this is equal to 0.975. All of this, because we add in the 0.25 and we add in the interval area of 0.95. So if we add in both of those together, we get 0.975 as the area to the left of b. And so now that we know that probability that z is less than b is equal to 0.975, we can look in the z-table for what z-score matches that probability. And in this case, we found 0.975 in the z-table, and we were able to match 1.96, the z-score of 1.96 to that probability. So then, now that we know the z-score, we can say that the probability that z is less than 1.96 is equal to 0.975. And so now that we found b, we found a as well, because we assume that they're symmetrical. So now that we found b, which is equal to 1.96, we assume that a is just the negative value of 1.96, so negative 1.96, and then we have our interval. So actually, whenever we are trying to find a and b, we're trying to find the intervals, it's actually not that bad, because you just need to find one side and you automatically assume that the other side is the same exact value, but just negative. So, and the reason why we got 1.96 is because when we look in the z-table, see, we found that the probability that z is less than b is equal to 0.975. And so we're trying to find the z-score that is associated with 0.975 probability. So all we need to do is look in the z-table and look for 0.975. So we found 0.975 right here in this blue box. And then we need to just check the rows and the columns for the z-score. So the z-score that we found was 1.96. So the probability that z is less than 1.96 is equal to 0.975. And that's exactly what we were trying to find in terms of step 3. When we start with the right tail, we use the z-table, and then by using the z-table, we can find the z-score that will help us find our overall interval. Any more questions? I know this is a little bit weird, but like, I hope that the more practice we can get with it, the easier it will be. All right, if you have still a question, don't be afraid, just think about it, and then you can always ask me later, or if you've thought of a question later, feel free to ask me. Like, I'm always happy to like explain it again. So let me clear this stuff. And don't worry, the workings like will all be in the slides that I share. So don't worry about that. But yeah, so again, this was whenever we were given the probability and not the interval. And I'm pretty sure you guys had some problems about this as well because, or like you had some homework assignment questions about it, just because when they asked for the shortest possible interval, that's exactly what they were asking, like what we just found. So now that we've basically practiced the standardizing, and then also we've practiced the probabilities of standard normal distribution, so just with z-scores, let's combine them together. And we're going to basically start with a normal distribution, then we're going to standardize it, find the probability, and then unstandardize. So this first one, we're just going to talk about a one-sided probability, or just with one z-score. So we're going to go back to our grades example. So x equals, x is, has a mu of 8.0 and a standard deviation of 0.2. So again, we have these important formulas that we need, to change from x to z, and then we're going to try to find the probability. So again, here are the graphs for reference. The top one is a normal distribution curve, and the bottom one is a standard normal distribution curve. So right now we are in terms of the normal distribution because we haven't translated anything into a z-score yet, and then we're going to standardize it. So this is asking us, find the probability that x is less than 8.1. So what is the probability that a score or a grade is below 8.1? And the only way we can find this probability is by standardizing this x value and then finding the probability using the z-table. So this is exactly what we're going to do in this example. So let's first let's first draw it out. So what is the probability that a score is below 8.1? So 8.1 is right here somewhere. And so this entire area to the left of 8. Whatever, delete that. The entire area to the left of 8.1, this is the probability that we're trying to find. So first, we need to find the z-score that matches this 8.1 x value, and then we can use the z-table to solve. So first thing we need to do is standardize. And the way we standardize is just with the equation that we did at the very beginning of the class. And also I gave it to you right here. And it'll also be on your formula sheet. So don't worry about that. But yeah, so first let's standardize. So we have z equal to the x value that they gave us was 8.1. So 8.1 minus mu, which is 8.0. And then we divide it by the standard deviation, which is 0.2, which they also gave us. So now that we have this information, we can see that 0.1 divided by 0.2. So in terms of the z value, we basically have it so that the probability, or the z score is equal to 0.5. So this is the first thing that we need to do in terms of standardizing. So we have z equals 0.5. So if we drew that on the standard normal distribution, we see that 0.5 is somewhere right here. So the probability that z is less than 0.5 is the same thing as saying the probability that x is less than 8.1. They're the exact same thing, except one is standardized and one is not. So now we can rewrite our question, or what we're trying to find, as what is the probability that z is less than 0.5. So that's what we're trying to find now. We started out with this probability that x is less than 8.1. We standardized the 8.1 to become 0.5. And now we can find the probability with this 0.5 in the z-table. So since the z-table could not fit on this slide, I will tell you guys the probability value. So the probability that z is less than 0.5 is equal to, let me just write it out again, 0.5 is equal to 0.69, yes, 0.6915. So that is the answer for the probability that z is less than 0.5. And then the last thing we need to do, like it says here in step 3, we need to put it in terms of x again, because they didn't ask us what was the probability that z was less than 0.5. They asked us what was the probability that x was less than 8.1. So when we try to put it back in terms of x, all we need to do is just type it out in terms of x. So the probability that x is less than 8.1 is equal to 0.6915. And that's all you need to do. And now that we've found this, we know exactly, okay, the probability that a grade is going to be less than 8.1, that has a 0.6915 probability, or there's a 69.15% chance of a student scoring lower than an 8.1 on, I don't know, an exam or something. So that's basically exactly how you would solve a one-sided or a one-sided probability, or a probability where you just are given one x value or one z-score. So that's exactly how this one would work. You standardize it, find the probability using a z-table, and then just put it in terms of x again. And that's exactly how we would solve a question like this. Any questions about this one? Yeah, this one is like not too bad, because really the main thing that you need to do is just to standardize it and then use the z-table. So this one's pretty nice in terms of like what all the steps that you need to take. And then, oh yeah, I did have the z-table. Wow. Yes, you'll see that on the slides. And so the last question I have to kind of wrap up this lesson is going to be one where we're talking about the grades example again. Here are the curves, and then also the important formulas. And now we're going to find an interval. So just like how we did a few slides ago, but now we are taking it a step further and putting it in terms of x as well. So we're trying to find the probability that x, between these two values that we don't know yet, a and b, is equal to 0.8. So that's what we're trying to find. What is a and b, so that the probability that x is in between these is equal to 0.8. So first thing we need to do, as always, is standardize this and find the areas to the left and right of the interval. So in this case, we can't necessarily standardize the x values because we don't know them, but we can rewrite this probability as in terms of z. So the probability that a is less than z, which is less than b, is equal to 0.8. We can already rewrite this probability like this, changing it from in terms of x to in terms of z. So this is what we're going to be trying to find. The probability that some interval, the probability that, some area within this interval is equal to 0.8. And then another thing, as always, that we should do is to draw it out. So we have our standard normal distribution curve. We have A and the mean, and we have B. So A and B right here. And we assume that this entire area in between A and B, so all of this pink area, all of this, we're assuming that that is equal to 0.8. So that's what we're assuming for now. And the last thing we need to do is find out what are the areas on both sides that are left over or not included in the interval. So what is this and what is this? And if you know what the answer is, so what is the value of this and what is the value of this, they are equal to each other. But if you do know the answer, let me know in the chat. So what is this area and what is this area? Yeah, so Lily, be careful with the decimal place. Yeah, exactly. Yeah, correct, Martin, correct, Ava. Yeah, exactly. So 0.1 is on both sides because remember this whole area or this whole probability is equal to 1. 1 minus 0.8, which is the probability that is the probability of this interval or the area of this interval. And then on both sides, we have 0.1 and 0.1 because 1 minus 0.8 is 0.2. Divide that by 2 and you get 0.1 on both sides. So now that we know the areas that are not included in the interval and the area that is included in the interval, we can now solve for these z-scores. So I'm going to move on to the next slide. It's going to have all the same information on it, but it's also going to have the z-table, so we can work through it together. So now that we have put this in terms of z, which I'm going to write again here, so we need to put it again in terms of z. So find the probability that z is in between A and B, and that equals 0.8. So now that we've done that, and then also here's a z-table, and then also, oh crap, sorry. And then also I'm going to draw out the standard normal distribution curve again. So here we go. So yeah, here's our standard normal distribution curve up in the top right. Here's our mean. Here is A, here is B. And we're trying to find this area in between. So I'm going to go with pink again, this pink area. This is what we're trying to find. And again, this area is equal to 0.8, and the areas on both sides are 0.1. So both of these are equal to 0.1. So now that we've rewritten this probability, we need to separate this interval as always. So we have, let's rewrite this as the probability that z is less than b minus probability that z is less than a is equal to 0.8. And so again, like I said in the previous slides about step 2, which is talking about starting with, or sorry, step 3, which is talking about starting with the rightmost tail. So we're just going to be looking at this one because we don't really need to solve for both B and A necessarily. As long as we solve for B, we know what A is because we're assuming that they're symmetrical. So now we need to find what is the probability that Z is less than B, and that is equal to, remember, the area of the interval plus the leftover area on one side. So we know that the probability that Z is less than B is equal to 0.9. And again, the reason why that is because if we see here, I'm going to do it in green. If we have the probability, that Z is less than B, and it's all of the area underneath this entire curve, anything less than B, we assume that that includes both the 0.1 that is not in the interval and the 0.8 that is in the interval. It's the area to the left of B. So anything to the left of B is included. So 0.1 and 0.8 are both included in this probability that Z is less than B. And so since we know that it's equal to 0.9, all we need to do now is look in the z-table for that probability. So we know we're looking for 0.9, or the value that is closest to 0.9. And if we do so, we see that 0.8997, here that I'm highlighting in dark green, this 0.8997 is the value that is closest to 0.9. So if we look at the rows and we look at the columns, we see that the probability that Z is less than 1.28 is equal to 0.9. Because again, we looked for the 0.9 first, the z-score that is closest to 0.9, we found that 1.28 is the z-score that matches that probability of 0.9. So we just found B. B is equal to 1.28. And now that we know B, can anyone in the chat let me know what A is? Yes, exactly right. Yes, Rosalie says negative 1.28, and that is 100% right. I also got another message that said negative 1.28. That is 100% correct, because as always, A and B are the exact same value, except A is going to be negative because it's on the left side of 0, and B is going to be positive because it's on the right side. So now that we know that A is equal to negative 1.28 and B is equal to 1.28 positive, we can say that the probability that Z is in between negative 1.28 and positive 1.28 is equal to 0.8, which is exactly what we were trying to find. So we found that we have negative 1.28 and 1.28 as our z-scores, relevant z-scores for this interval. So we found that that equals 0.8, which is exactly what we're trying to find. And the last step that we need to do is that this problem, even though in our previous example, we had, the problem was asking us just to find the interval in terms of z. In this case, we need to find it in terms of x, because if you can see here, this is asking us to find the probability that x is in between these two unknown values. So in this case, we need to turn a and b in terms of x as well. And the way we're going to do that is just by unstandardizing these two z-scores that we have. So now we need to unstandardize and change these two z-scores. So this negative 1.28 and this positive 1.28, we need to change it in terms of x. So using this formula, the one that I'm highlighting in red at the top. So we need to use this formula and change this negative 1.28 and positive 1.28 into x values. So I want you guys to do that on your own using the formula. And again, the mu and the standard deviation that you need are in the top left corner. And I want you guys to let me know what you get for the what A is equal to and what B is equal to. All right, in terms of time, I don't want to go over by too much. So I'm gonna go ahead and also do the problem alongside y'all. So this is one that is a bit tricky because just because A and B are symmetrical in terms of z-scores, that doesn't necessarily mean that they're going to be symmetrical in terms of x values. So for this first one, x with negative 1.28, so x equals mu, which is 8, plus negative 1.28 times the standard deviation of 0.2. So for that, we get the answer of 7.744 for the left side. And then for the right side, so 1.28, we have x equals the same thing, so 8. But in this case, we have plus 1.28, so it's not negative. And then we have a times 0.2. And that gets us an answer of 8.256. So this is a little bit tricky. Really make sure that you're wary about this. Just because the A and B values are symmetrical for z-scores, they're not going to be symmetrical, not likely going to be symmetrical for x values. So that's why we need to be just really careful about that. So in this case, we have found our A and B for x. So now we can fully write out the correct answer, which is the probability that x is in between 7.744 and 8.256 is equal to 0.8. So that means that there is an 80% chance that a student will score in between 7.7 and 8.3 on a test or something. So that is exactly how you would solve this type of question. So we took it a step further by using x, or using it in terms of x this time instead of just z. And most of the time the exam questions will be like this, because if you keep it in terms of z, you can't really, apply it to something, like it's always standardized. But in this case, we can actually take a look at these numbers that are in terms of x, and we can actually make some sort of conclusion about it and say, oh wow, like 0.8 of students are going to be with these grades, so that's applicable. Do you know how strict they are with notation on the exam? So with notation, I don't think you'll have to write out like the actual, this like this part right here. I'm going to circle it. I'm not sure if you're going to have to write out this part specifically on the exam. They might just ask you, like, they might just give you like this part, like this P, and then leave a blank space for you to type in the number, and then leave another blank space, and then like ask you to type in the number. And then like obviously this won't be given to you. So in terms of that, most of the open questions are you just type in a number, like you don't have to necessarily type in words or anything like that. But sometimes they have some like drop down questions. So maybe they'll ask you to like drop down on this part, like this X part, and ask you, oh, is this in terms of Z or is it in terms of X? Like, and you need to say which one is correct. Or like maybe something with the signs, like they're going to ask you which sign is correct, you know, something like that. But in terms of writing out the whole thing on your own, they're not going to ask you to do that. But yeah, so that is going to finish up this problem. If you have any questions about any of these things, all of the workings are always going to be in the slides that I share with you guys. But yeah, if you have any questions, you can always feel free to message me as well. So we did a lot today. Like you guys did a really, really great job with all the things that we did today. So normal, standard, and standard distributions, and then the probabilities of these, and obviously practice over everything. So that is basically going to be it for today's free session. Again, thank you guys so much for coming. I really hope it was helpful, and it's going to help you guys review for your exam. And yeah, amazing job. Check the WhatsApp group chat, and then also I'll send the email with these slides. And if you would like to come join me on the full course, that's going to be next Saturday. So I hope that I can see y'all there if you want. And then last thing is just make sure that you fill out the feedback form after this lesson, because yeah, it's really, really helpful for me to know what exactly you guys are struggling with and what you think of these types of courses, so we know that we should do them more in the future. So yeah, again, thank you so much. Please stick around if you have a question about anything. But if not, you are free to go. And yeah, have a wonderful day. I really, really hope you guys wish you guys luck with this week and your exams next week as well. So yeah, bye guys.
Bye, thank you very much.
Bye, thank you so much.